All right, so here we're supposed to find the limits. All right, so, oops, went too far. We're supposed to use theorem 3 here. So limit of a polynomial and rational function. So if we have a polynomial, some f of x, and we're finding the limit as x approaches c, well, that's just going to be f of c for any polynomial function. So basically, we're just going to plug in c into the function, and we'll get our value out. Now, the limit of r of x as x approaches c is equal to r of c for any rational function with a non-zero denominator. So again, that denominator really you have to pay attention to the denominator not being 0, and that's at x equals c. So basically, again, we're just going to plug in c into those as long as we don't get 0 in the denominator. So what does that mean for a? So if we're going to find the limit of x to the fourth minus 2x plus 3 as x approaches -1, well, we just plug in -1 into there and we get our values. So we can say, okay, well, that's going to be basically f of -1, which is going to be -1 to the fourth minus 2 times -1 plus 3 minus 1 to the fourth. That's going to be what? That's going to be a 1. That's going to be plus 2, and that's going to be plus 3. So that's going to give us 6. And remember what we did last time, when we broke it down and we found all the limits. But really, this is a nice theorem because it says any polynomial, we can get this. All right, so what about this one? Well, the same thing here. We can just say, okay, well, it's a polynomial function. It's just to the power of that. So for b, we're just going to plug in 2. So that's going to be f of 2 is equal to what? Well, that's going to be the square root of 3 times 2 squared minus 6. 2 squared is 4 times 3 is 12. 12 minus 6 is going to be 6. So that's going to be the square root of 6. And that's an exact number. So let's just leave it as that, and we'll leave that for our answer. Now here, we're going to take and plug in a -2, and as long as the denominator is not 0, we can do that. Well, -2 squared is 4, plus 1 is 5. That looks like it's going to work. So we just have to say, well, what is f of -2? So that's going to be a -2 squared over a -2 squared plus 1. So that's going to be what? That's going to be a 4 over 5. Okay. And so that would be our solution to that one. And again, this really is nice because it lets us plug in things that we can do, and we don't have to use all the other theorems to figure it out. If it's a polynomial or if it's a rational function with non-zero denominator, that's all we have to do. All right, so what about this one? Okay, so we're coming in from the left on the -5, and so it's going to be less than 5. Well, that means it's going to be this one. And so we want to find the limit of f of x. And so basically, we're going to just plug in the 5 value, and then we're coming from the left side. And so really what happens is we're going to have two pieces to this function. One of them is going to be, something like that probably. And then the other one is going to be something like that. Well, I'm not exactly sure what it is, but it's going to be something similar to that. So for A, we're coming from left, so we have to use the first function. So we want f of 5, and we use the first one, so it's going to be 2 times 5 plus 3. So that's going to be 13. Okay. Now here we're going to come 5 from the right, so that means we're going to be on that side. And so for B, what do we have? Well, we're just going to say f of 5 is equal to a -5 plus 12. So that's going to give us a 7. All right. Now, what about the limit of f of x as x approaches 5? Well, those two are not equal. So c does not exist. Okay. And hence, part D, that means f of 5 does not exist as well. Okay. So if those were equal, then yeah, we would get that, and then we could also get this one. If they did, that meant they would be coming together at the same place. But these are not coming together at the same place. Therefore, that doesn't exist, and C doesn't exist either. All right, so let's look at the next one. All right, so here we're supposed to find the limit of each problem. Now, sometimes if we look at this one, if we plug in a -3 here, guess what? That goes to 0. But can we make this simplified? And the way we do these to simplify them is factor. And so can we factor that numerator? Well, that could be x plus 3, x plus 1, and then that's all over x plus 3. Well, guess what? When you do that, those cancel. And really, this is saying now find the limit as x approaches -3 of x plus 1. And so that's what our problem has now become. And so now, can we do that problem? Yeah, we've gotten rid of this discrepancy of the x plus 3's. And so this would be kind of like where a vertical asymptote is. And so that would give us, it would get rid of it here when we do this. And so then we just plug in -3. So -3 plus 1 is going to give us a -2. All right. What about this one? Well, if we follow the same thing there, that's going to be x plus 4, x minus 4, all over absolute value of x minus 4. Now, this is still the limit as x approaches 4. Now, can we cancel here? Well, this is x minus 4. This is the absolute value of x minus 4. Here we cannot reduce. And because we can't reduce, then this doesn't exist. Okay, so if you can reduce it and then you can take a limit, then that's fine and you can get your answer. But if you cannot reduce it because these are not the same, then you just get it doesn't exist. All right, so let's stop there and we'll come back for a little bit more.